Hi guys, welcome to another LER I electronics repair video. I picked this up the weekend at the car boot sale. It's certainly seen better days. High-low musical A25W H&M, and I know nothing about this apart from it was lying around, and the guy who I got this off is a regular there. He's one of the ones I'm sometimes trying to scrounge stuff for the channel to repair, and he said to me, "Rich, do you want to see if you can fix this as a challenge?" And I said, "Yeah, sure." He says, "Well, give me €10 for it then." No, actually, he wanted €15. I said, "You're joking?" He says, "Well, you'll have some fun with that." So anyway, in the end, I said, "I'll tell you what, I'll give you €10 for it," which he took. I'm not surprised. And I thought, you know, apart from seeing a lot of rust inside it, there's some hefty transformers, and it might be useful just to use the case. You know, I could spray this up and use this as an enclosure for some project or other, which makes me think, for the sake of like €10, it's probably worth having. But the thing is really to see, can we actually get this working? Now, the guy who sold it to me at the vast sum of €10 also told me that it works. Whether that is true, I don't know, is the honest answer to that one. And I rather hope he's not telling me the truth, because I rather hope this wouldn't work and give us something fun to look at. So, you know the background story to this one. This, I think, is going to be, if anything, a bit of a restoration job. Or, as I say, I can use the case and clean it and spray it up and make something interesting out of it. But the first thing I think is, well, we need to get inside this thing. At first I thought this was something that was homemade, but I don't think actually that is the case. It has connections for a 100-volt line. This is like distributing sound around a restaurant or somewhere or other with playing music in the background. Yeah. Looking at these sockets on it, I suspect this is probably quite old. I mean, these DIN sockets, I know you can still get them, but I don't think they've been used really since, well, the 80s maybe. So this could be from the 70s or 80s, I don't know. Power, voltage, 240 volt. Power, well, red actually means like network, really. Off an amp, then it's got, oh, this fuse is gone, yeah. That fuse is gone. That's so it doesn't work, yeah, because the fuse is gone. I'll point that out to him next time I see him. So that's what we have on the back. And I guess we need to have a look to see what's inside this. So let's see if I can figure out how to get into it. Maybe some screws under these feet. No, do these come off? I don't know. I mean, there's screws on the front panel come off. So I'll undo these first, and let's see if I can figure out how to get in this. I mean, we could just plug it in, but nah, the fuse is gone. Yeah, the fuse is gone. Let's see if we can actually unseize these screws. Need something a bit bigger than that. Yeah. It doesn't sit level because the power lead, that doesn't help. Okay, so there seems to be the first problem. Oh no, okay, I think there's a case like there's always one, yeah? There's always one that you can't undo. But that one came out easily. Let me see what else I can do, and then we can see what's inside it. Okay, there was 2 screws either side, and that seems to have got us somewhere. Yeah, we can get into it now. I think it slides out. So guys, is it just me, by the way, that loves a challenge? Or am I not the only one, yeah? Are there others of you who get in the comments below who love a challenge? Would you fancy having a go at this thing? Okay. Well, that's what's inside it. Plenty of corrosion, but I knew that already. a lot of sand. You can probably see it on the desk, this sand. We get a lot of this here. I get a lot of this here with the Kalima. You know what? I'm going to explain the sand here one moment just so you can see why we get so much sand here. Quick geography lesson. So this is where I live. This is Gran Canaria, and I live down here in the south in the area called Maspalomas. And I used to live in this area called Puerto Rico. And by the way, that is Puerto Rico, Amadores Beach. But anyway, that's where I am. And if we zoom out to look at the world map, you'll see that to the west there's nothing but ocean until we roughly reach Miami. I think we're about 65 miles north of Miami. If you went that way, you would come out somewhere in this area. And if we go the other way, well, you see from here, there is nothing but desert until we reach India. Yeah. So this is desert, and this is full of sand, and the wind blows that way, usually from east to west, the trade wind. So what happens is, quite often, this, you see, where all that desert doesn't stay where it is and it comes off over here, and that's me. So that's why we get so much dust and everything over here. It's not that we're messy or untidy, it's just that that happens. And when that happens, it can be 10 degrees hotter than normal, and it can be very dusty. It can be just dusty, it can be just hot, or it can be both. And this happens winter or summer. So winter normally is 22, 23 degrees, and it can be 32, 33. And summer's normally like 32, and it can be 42. Geography over. That's why there's so much dust here. Anyway, back to our amplifier full of dust. And there it is. And this is Sahara, yeah, basically. So that's what we have. As to how much of this is actually rust and how much of it is dust, the only way to find out is try to brush that off, yeah. And for some reason the paintbrush I normally use has gone missing, but I have this one. So we can spend a little bit of time just removing the remains of the desert from this. And it might come out looking rather better than it did. That was only set to about 100 degrees, by the way. It's just to blow out dust more than actually using to heat up. Let me try and get a fan as well. Okay guys, so that's our amplifier minus the dust, minus quite a lot of the fluff. Still a bit grubby, but it looks considerably cleaner than it did previously, that's for sure. I'm still thinking this, because we have a lot of these capacitors which are kind of like axial rather than radial. This is probably from the 70s. Oh, it could be 80s, but it certainly has some vintage to it, that's for sure. So now we've got rid of the dust, we now have the rust. So this rust is not because this thing's been put out in the rain. This rust is for the same geographical reasons of the dust, basically. So there we have it. Two transformers. This one, yeah, it's connecting to the voltage selector switch. So this one is the mains transformer. So this takes your mains voltage in and then generates the voltages for the amplifier. This one is effectively an output transformer. So in this case, the output from the amplifier drives this transformer, and that goes to this connector, and then we can either have a normal 8 ohm speaker, or we can have the various high voltage speakers, which is 100 volt line. So you can use a normal speaker, or the ones where you would have lots of small speakers all around the building. I can show you what I mean. These are 100 volt line speakers. You can see they have the same 100 volt line marking on them. and again you have the different taps on them which connect to here. So these are the little things that go in the ceilings in, you know, shops and restaurants and places like that. Yeah. So this amplifier will in fact be a mono amplifier. It's not a stereo amplifier. You have bass and treble, I'm pretty sure, volume, and then you have a microphone so you can actually come and voice over the music for announcements. These buttons are, yeah, they're jammed, so we can see that the switches are not working. They're seized up basically. I mean, that one will release. That one is with a bit of persuasion, and these two not really. So that's something we need to look at as the switches. So we do have at least one fault on this. This has a 48 volt supply rail. I can see marked on here, 48 volts. So if we decide not to use this as an amplifier, this transformer might be useful for building something like a bench power supply, at least, because if it's 48 volts, I suspect it can supply a couple of amps or something. I don't know what the rating of the transformer is. We could find out. So let's let's get this circuit board out. Let's replace this fuse holder, and then let's see if this will power up. To do this, I'm going to take the front panel off. Yeah, knobs and front panel off, and then I should be able to get this PCB out. I'll probably have to desolder and label up some wires, but then we can get the amplifier module onto the bench on its own as well, and possibly do some diagnosis on that before we think of effectively putting this all back together and fixing the various problems. So I'll get this front panel off first, and then we'll dismantle this further. Okay, you can see I was having a lot of trouble with this one. The little grub screw is completely seized up on it. Can't even get in there at it. So that's not coming off anytime soon. Yeah, well, I've kind of got the rest of this coming apart quite nicely now. So it looks like this front panel is effectively held on by these little plastic inserts, so we can get these off. Yeah, they're coming off a little bit. Yeah, it's coming off. Maybe just persuade this one a little bit as well, and I'm thinking maybe there's some more screws behind this then. Yeah, that's coming off. There's one more screw in the front here which I need to release. That does not want to give it up, not easily, but one way or another I need to get it. Okay, so this is held on with two screws. This looks almost like it's some sort of botched job, but it does fit in there, so I can't see anything other than that was, you know, how this was originally made. But there's a couple of screws down in here, so I think we can get these out, and I can probably take this out altogether and figure out how it's wired to the amplifier. Yeah, that's coming out okay. And there's another one just in here, and then this should come out. Or so the theory goes. Well, it's loose, so that's a good sign. Yeah, it's a good sign it's going to come out. Let's see. Okay, there we go. Yeah, so this will effectively, should in theory or in practice, come back out of here. So we get the little screws out first so they don't go missing. So that one. So well, it obviously was put on effectively on the outside, but we can see where this lot are going. These are all going to this transformer. Okay, we have a black wire coming from, I'd say, the negative end of the bridge rectifier by the looks of it, and that goes to here, which effectively is 0 or ground, and then we have another black wire from the same place which goes to the transformer. This blue one comes from the 8 ohms output on the back of here. This thing here that says 8 ohms. So that's this blue wire. So I'm guessing this is the output from the amplifier and this is ground. Yeah, that makes sense, because that's where they're connecting to on here. They're connecting to 0 and 8 ohms for the normal speaker. This then obviously is the ground to this transformer as well. So you would think, coming from the main transformer, you would have a ground connection, but I don't actually at the moment see where it is. From here we can see brown and blue, so these are coming in via the fuse from the main supply down here to the on-off switch, and coming out we are, or is it probably the brown and the black are coming that way, I'm guessing. That goes to this transformer. Let's see, the blue, no, the brown, looks like brown and blue come to here, and then black and white come back out of here. Black goes to the transformers, that's going to be one end of the primary. Then the white, yeah, the white goes to the other end of the transformer here, and it also goes to this little selector switch, which is a voltage selection, and that's wired back to all these different taps on the primary here. So from what I can see, the only wires coming to the amplifier are these two, plus and minus. I don't see that this is a, you know, a symmetrical plus and minus supply. We just seem to have one supply. So okay, that's interesting. I think what we'll do is now we'll try and get the amplifier off. That's just the LED, the power LED. We'll get this amplifier module off. We'll disconnect these. I'll just kind of like label them up, and then we can get us on the bench and actually have a look to see what we have here. I've unsoldered those wires. Now let's see if we can make some sense out of this. So this is obviously a secondary of the transformer. It goes to the little bridge rectifier, the diodes here, little bridge rectifier. So this is an output, and we can measure that coil. Yeah, it's about 5 ohms. Does that go to any other point on this transformer? Well, obviously this is the two blue wires, but does it go to anywhere else? No, not on that one, and I don't think it would on this one either. No, so we don't have a centre tapped supply, otherwise there would be some other pin connecting to here. That means that the blue one coming out, we know goes to where it says 8 ohms on the back of the connector here, 8 ohms. And the one that says 0 is the black one, and that also goes to this transformer. So that's what we have. Everything else is either mains wiring through the voltage selector, or its outputs via this transformer to here, the options for 50 volts, 70 volts, 100 volts, okay? So that's what we have. So on the amplifier, this is where I desoldered the black wires from. And this is a bridge rectifier, I can see that. So this here, just go to, yeah, continuity. This goes to the negative end of this large capacitor. Does it go to this one as well? No, goes to the negative end of this one though. So this appears to have a single voltage rail supply. If I go to the other end of this capacitor, it should go to the positive of the bridge rectifier, which will be the two ends with the stripes together. Yeah, I think it does. Yeah, get a connection on it. Yeah. So this has a single supply rail. That would tell me that both these transistors are the same sort, and probably both NPN or both PNP. And this is a class A amplifier. It's not a push-pull with complementary output stages. It is a class A amplifier, which is the least efficient, but some say the best audio quality, and technically speaking it is the best audio quality. So another few checks around this. We can get our meter on continuity mode. These connected together? Actually not, so I need to figure out how this actually works. Let's have a look to see if these transistors are actually the same as each other. Here are the output transistors, and they're a bit corroded, but I think you can probably see TN3055, which is a very common power transistor, NPN, and this one also looks like a 3055. If it was the complementary, it would be a 2955. Let's make sure I get a contact because they're quite corroded. They're not in parallel. I thought maybe they would be in parallel, but they both have a number 4 on them. Somebody's put there with felt pen many decades ago, which tells me these are being matched, or they were matched for gain, so that was important in the circuit. So we have two NPN transistors by the looks of it. This is where the microphone volume comes in. This is where the selection from the front panel switches comes in, and we have a lot more dust. So the next thing really is to clean the rest of the dust out of this thing. Okay, that's some more dust out of it. I'm tempted actually just to take this PCB off here and just to wash the whole thing in the sink and then let it dry overnight actually. To do that, I'm going to unsolder the wires from these various switches. This needs looking at anyway, to be quite honest, if we are going to repair this. And they're all in order, like the resistor code, you would think, but they're not. Brown, orange, red. They're kind of in an order like the resistor code. So what I'll do is I'll actually just take a photograph of that and then unsolder the wires from it. And then we can get this PCB off and we can have a look tomorrow once it's been in the sink to see how it's looking. I'll just do the necessary thing and get a photograph first of the order of the wires. So here we go. Got my just literally get a photograph on the phone. Okay, yeah, that's good. Right, let's unsolder this lot off here. This shouldn't be too difficult to do, to be quite honest. Might need a little bit of flux, or they might just all come off. Yeah, they're coming off. Yeah, they're kind of just falling off. There we go. It's probably a good idea with this sort of thing, effectively, to dismantle it anyway, if you're going to have some chance of getting it to work. Quite what I would do with it if it is working, I don't know, but it was a challenge, yeah, and challenges have to be accepted. And if we don't get it working, we can learn some stuff. Like when to leave things alone, yeah. Useful lessons like that. Okay, so I have the whole PCB now loose. I'll take the PCB off the metal backing plate, and this is going to go in the sink. Okay, there's the amplifier PCB removed from the case, so I'll get this cleaned up, and then I think we can probably effectively test this on the bench. I mean, we know where the power comes in, it's the bridge rectifier. We know where the output to the speaker goes, and we can connect an 8 ohm speaker to this and power it off the bench power supply and see if it works, I think. Right guys, new day, new shirt, and this went into the sink yesterday, so it's nicely dried out now. It's much cleaner. I'm thinking actually this capacitor might be a replacement. I'm not sure if that's the original one that's kind of stuck in there. It's not the same value as this one, and they're not in parallel. I think this one is probably smoothing the incoming voltage from the bridge rectifier, which is on here, these 4 diodes. And I think the other one looks like, yeah, it's connected to the speaker out. So this point here is actually the connection to the speaker, and it comes through this capacitor. So that's effectively in the speaker out, which again makes me think this is a class A amplifier, if the fact we have a single voltage rail didn't give that away. So apart from a bit of corrosion, especially on these transistors, it looks okay. Next thing then is let's have a look at this switch assembly, because this is all jammed up. I've just made the note of the colours black, brown. I've put a blue line around there. That's supposed to be a W. So I can remove these wires from here, and then we can figure out how this works and what's going on with it. When the power switch is working and this one goes in, it will come out with a bit of effort, but that's it. These two seem to be stuck, and I'm not sure if these are supposed to be that you can push one or the other but not both. Okay, so we can get some solder. This is my one I've had for years. I mean, you see I'm almost down to the last turn now. This was a 500 gram. This is why I'm stocking up a bit on leaded solder now. You know, I bought this one and thought it'd last forever, and it was doing very well, so I started the channel. But I'm putting it to good use, yeah. We can say that. Okay, so these should come off here fairly easily, and then we can have a look to see what the switches do, and then I should be able to test the amplifier once I figure out which connections to make, effectively simulating the switches, or just fix these switches. Then we should be able to inject an audio signal and power this up from a bench power supply, actually, I would think. I mean, it's 48 volt supply, but I'm sure it'll quite happily run at 30 volts from my bench PSU for testing at least. Okay, so now we've sorted that lot out. Here's the switch assembly. So I'll take it off the metal bracket first. Now let's see if we can figure out why it's seized up and whether the contacts are actually any good as well. Okay, so we have this one and one more screw. Okay, there. So there's our switches. I think there's supposed to be something in this mechanism that makes it effectively latch one or the other. But it's very corroded, and I can't move these two. These are both stuck in. We can have a look. So we have connections coming in, and this is our front panel. So this goes this way round. So the red button is the power button. This is your power button. And then we have magnetophone, which I'm pretty sure without translating it is tape, I would think. I'm not sure what HM is. I'm guessing it's another audio input. And then we have microphone, which we don't really need to use at the moment. And on the back of the amplifier there is some connections here. And if we look on this, we can see we have microphone, we have HM and magnetophone, and that looks like a picture of a tape as well. So I'm going to try and set this up. Yeah, you can see, like, this is in and out. Oh, right, okay, so this is for play or recording, and this HM is just an input. So I think we can use HM to put some music into this. I mean, we should be able to use either. So let's have a look to see how that switch is wired up. So once again, yeah, HM is this one. I'll just make a little mark on it because it's easy to get yourself confused with this sort of thing. So this is HM, this one. Now let's see how it works. And I'll just zoom down a little bit. We can see the meter, so I'm on just continuity range. this is magnetophone, and we can see this has only been used as an on-off switch. So when this is pushed in, these 2 points connect together, and this point connects to the top of this switch. But that goes no further unless this switch is out, connecting to here, and that then goes to that one. The other one looks like an input here, so when the switch is in, that connects to this one. Is that the same one? Yeah, so basically this switch in or out will connect this point either to this one or to this one, depending if this is pushed in. So we can say quite definitely, I would think, this is an input and this goes to here, which is an output. So if we connect those wires together, we'll just solder them back on here because the switch is in. Then if we put some audio into the magnetophone input, it should come to here. The fact this one's stuck in as well isn't going to make a difference because this one is jammed in and this needs to be out for this input to work. That seems to be the case, but we do have these two which also connect together. Let's see if we can unjam this switch. If we can unjam this switch and put it in the out position, we know definitely with this one in, we can feed the input into this input, which is the HM. Okay, that's the best way I can see that. Let's just test these switches as well. So this one is on, stuck in the on position. And do we have a connection? Well, actually, no, we don't. That doesn't seem to be good. No, that switch doesn't seem to be good anyway. How about this one? This should be between these two. Yeah, we have a contact there. That switch is working. Okay. This one is off at the moment. But if we push this one in, yeah, that switch is working. Yeah, that switch is working. The microphone switch. So this switch doesn't appear to be good. Let me just see if we can... Oh yeah, okay, so we have got a contact on that switch. On that side at least. But not this side. So I think what the first thing we'll do is take these switches off. And let's see if we can sort this problem out. I think this little metal thing down here is something to do with the interlock. Just yeah, no, it doesn't still operate. Okay. Ah, I've sorted it. Did you see me do it? So I just flick this little thing here forwards. And this one now operates. This definitely appears to be part of the mechanism. Let me find something to move it. So we'll push that one forwards. Find something a bit better to do it with, okay. Yeah, that switch now, effectively, yeah. That's latching. It's just the mechanism's corroded, basically. Ah, yeah, and this is now working. Okay. Well, we have it working enough to test the amplifier at least, and then maybe we can figure out if we just clean all this up. But that's definitely operating now. I thought it was designed that way, and this one is operating but not always latching in. Probably just a bit of WD-40 might help this actually. Let's give it a go with a bit of that. Just put on a bit of a kitchen roll and let's give this a go. This is actually WD-40 and switch cleaner, but it'll probably do quite a good job of it anyway. Okay. Let's give that a clean. Let's see how well it works now. I'll just dry it off a little bit. It actually feels cold with that stuff. Okay. Let's see what happens now. Yeah, that operates correctly. And then this one. Yeah, so that's basically what that needed, really, some switch cleaner. This one's still a little bit sticky. Still something to do with this little metal thing here. Yeah, seems to be working well now. Right, I can connect the wires back to this from the main amplifier. Then let's use our bench power supply to power the amplifier up so we can monitor the current. We'll probably check for a few shorts and obvious things first. And then let's see if we can connect to a speaker and get some sound out of it. Well, now we've cleaned it, we'll just check the contacts on this and then we'll look at the amplifier module. So, is that now making the contact? I'll just put it into a continuity mode. Okay. Yeah, this switch still isn't good. Probably have to take that apart. Let's get that to work. So that effectively is now in the off position anyway, so we can ignore the fact that's not working. We can always bridge that with a bit of solder, that's another option. This one's now in. So yes, we have a contact there, we have a contact there. Okay, and then this will go to the output here. Just make sure we get a good, this one. Yep, that's good. The microphone we can just leave out. So it's working in that position. In this position, these contacts in the switch are no good. These are okay. So we'll use that position to test first. If we get the amplifier working, I'm sure we can unsolder this or get some cleaner inside it or otherwise solve that problem. Okay, I'll solder these wires back on for now. I've soldered the wires back onto the switch in the same order they came off. I took a photograph. They obviously mixed up the resistor color code order, if that's what they were trying to copy. It should have been brown, red, orange, yellow, green, blue, but that's how it was, so I've put it back together that way. This switch now, which is the HM switch, is actually functioning. So I've used some switch cleaner on it. And you can see now, I get a good contact on it. So that's now working. I'll check this amplifier module now. Let's just look for some obvious shorts around the output transistors. If they test okay, then we can connect an input to it, and let's see if we get any sound out of this running through my bench power supply. So to check the transistors first, these are the output transistors. We'll go on to diode mode. They marked base emitter, actually marked on the board quite nicely. Interesting, someone's tagged these bits of wires, but that's how it is. So, base collector is an NPN transistor and we're in a junction. Base emitter, I'd expect that to be quite low because there'll be a resistor wired across there somewhere. Can't quite see where it is, but there would be a base emitter resistor. And this you'd expect to read the same. Similar. Yeah. We can live with that, I think. Base collector reads, yep, junction, and then collector emitter should read, well, with the positive to the collector, it's just charging the capacitor. So that's fine, there's no short there. And there's no short on that one either. So I'm quite happy to connect this up on the bench power supply with a current limiter. Now we need to figure out which input we use. I'm going to use the one which I've now fixed the switch for, which is the HM input. So let's have a look on the back of this. So if I can get it to focus one moment. Okay, that's good enough. This is the input. And we can see we have 1 and 4 are not used, 2 is ground, and 3 and 5 is the audio input, so it's mono, as I said. So that is the, let's see, the fuse goes towards the top. That is the third one down on the back of here, and that reminds me the fuse is gone, so we need to sort that out first as well. So this is the input we're going to use. I'll just put a little mark on it, so it's very easy to get confused when you're doing this sort of thing. Certainly for me anyway. The fuse holder's broken. So what I'm going to do is, because I'm going to use my bench power supply for now and I can limit the current, I'm just going to bridge this for the moment, because I have an other way. Otherwise, if you were going to run it from the power supply, you need to put a 1 amp fuse, even if you solder it from here to here. But because of the way we're going to test it, let's just bridge that out. So here's just a little bit of wire. Somebody gave me bags full of this stuff. It seems quite good because they stripped on the ends already, which is quite nice. And the insulated sleeve doesn't seem to melt back. I think it might be PTFE wire, which is nice if it is. So we can just tag our wire on here. Okay. Then we need to find the input, so we know it's this one with a mark on. So yeah, you can see ground's in the middle and this is the input here. So this is where we're going to feed our audio in, and this is ground. I'm not sure I've got any DIN plugs. Let me have a quick look, but if I haven't, we can just solder a bit of screened wire on here to a phono socket and then connect that way for now. I didn't have a suitable DIN plug for this, but I can fasten this on. So this is just a couple of phono sockets. So if we tag the ground pin onto here, I can then just take a small bit of wire from one of the pins to here, and we can inject some audio that way. So we'll go onto this, is obviously ground, and we'll attach our socket to this. I have to just turn it to an angle where I can solder a little bit more easily. See if that's got it. Yeah, it's attached now, so we have that one. And then we just need to put another short bit of wire. We'll use one same as the other one. I mean, it should be shielded wire, but it's so short it doesn't really matter. Guy gave me these, by the way. Does anybody actually know what this stuff actually is? It seems to be a few different thicknesses. What these are supposed to be meant to be used for, there's no labels on them. But it seems like quite nice stuff. He has a mobile phone repair shop. Was that any sort of clue as to what these things are actually supposed to be for? I don't know. Okay, let's go on to this one. Okay, we can tag our wire. Okay, so that'll now do that. So we have an input. Now we need to connect a speaker and the bench power supply. Okay, so we're basically ready to go. Sorry, you hear a bit of noise from the power supply there. The speaker I've attached here, so you can see there's an 8 ohm speaker and negative. So these are the speaker connectors. The power I've actually tagged across the main capacitor. This point here anyway is marked negative, and the red lead, if you look just where the track goes here, goes to the fuse. So that's the positive input. The bench power supply, I can now turn this up to 31 volts, it's maximum. We'll just turn the current down. Then I'm going to short together the two leads. And let's set this to, well, the fuse is rated at 1 amp. So we can set it to around 1 amp. Okay? And we can now connect our wires, and let's see what this actually does. I mean, the worst thing it can do is draw 1 amp. But you'd assume with no input to the amplifier, it'll probably be in a fairly quiescent state. Let's have a look to see what happens when we connect this wire. Oh, well, it didn't like it, did it? That's what happened when we connected the wire. So it's like we have some sort of short somewhere. Let's turn the current down. So it's turned down now. Again, I can just connect to the thing without sparks this time. I don't know if you saw the sparks or not. The current's now turned down. Let's see what we get. Okay, well actually, whatever caused that to spark has now gone open circuit because I can't turn the current up. So it appears we have some sort of short somewhere, where we had some sort of short. I'm not coming through where the fuse is wired up. So let's have a look with the test meter. Let's see what happened there. Let's get the test meter on continuity. So this is where I have the power coming. Oh, it made a noise. That's interesting, isn't it? The power's on. Well, no, the power's on, and it now made a noise. Got some voltage coming out. Let's have a look. I touched something on the circuit board then. I got some feedback as though the amplifier is actually working now. That's probably why it's not drawing any current. It shouldn't really do when it's quiescent like this. Let's go to the volts range. I can't imagine that sudden amount of current was anything to do with the capacitor charge. Not that much. It would surprise me. I mean, it's a big capacity. You don't know. Okay, we have 32 volts coming in. That's good. So it's powered up. We can say it's powered up now. That's the first thing. It's also made another buzzing noise when I touched it. Let's connect our audio source. So I have a cable coming from the mixer, which we can connect into our little socket here. Probably get some more buzzing noise again. Okay, nothing there. That's fine. Let's now try to see if it's working. I mean, the first thing I'll just do, I'll take my finger on the meter probe and just touch it to the input. Yeah, I've got a little clicking noise on the speaker, so that suggests the input's actually connected. See if the focus is also good enough. Yeah, sorry about that, guys, if it's a little bit out. Yeah, I'll get a bit of noise. Let's find some music and let's see what it does. Okay, I now have some audio. Well, there should be sound playing through that now, and there doesn't seem to be. That should actually have audio on it. Unless I have a bad connection somewhere in the wiring from my mixer. Ah, okay guys, I sorted it actually. The reason I've got no sound is because I'm actually not on the input I thought I was. There we go. So the amplifier is working. I thought it was, to be quite honest. Bit of funky music, of course. Okay guys, so that amplifier actually works. With a little bit more volume, yeah? Oh guys. You could say I have an infantile sense of humour, because I've just discovered what it does when you turn the power off. Ready? Oh, I love that, guys. You want to do it again? Ready? Small things, small minds, eh? There we have it, guys. A little bit of restoration work. The question now is, what shall I do with it? I mean, I bought this for fun. €10, and I'm sure I've had €10 worth of fun out of it. I think that noise when you switch it off, that's worth €2 just on its own for the laugh it gave me. But we have, basically, this is the chassis. So this is a 48 volt transformer. And I don't know what the rating of the transformer is, but the fuse on the back of here is 1 amp. So I'm guessing that's a 1 amp transformer, or the 1 amp was more designed to protect something in here in case of a fault, and the transformer is rated at more than 1 amp. I'm not sure. I could find out. I mean, it has a number on it. I mean, it's quite old. Whether that would tell me anything, I don't know. This is the transformer that drives the speakers. I mean, that's effectively a step-up transformer, basically. So we connect the 8 ohm input, and this steps up to 7500 volts AC, and we have a few bits of metal, so all this effectively forms the case. Now I could take the front off here, which is a bit difficult to get off. I might be able to actually get it to come off. Yeah, it's going to come off. I can take the front off here and then effectively mount just a plain piece of aluminium to this and have a completely plain front. And I can do the same with the back. This back panel comes off. I can take all this stuff out of it and just put a piece of aluminium or even plastic. So I could in actual fact use this case, and this I'm sure I can just clean and spray it. It'll look quite nice. So I could use the whole chassis for some sort of project, something that I might want. And to be quite honest, I'm sure if I can use this, it's worth more than €10 just for the metal work. This, I mean, it's a little amplifier module. I could use the power transistors, maybe build something like a dummy load into this, maybe using these, or some sort of power supply. Whether the transformer at 48 volts would be useful for that, given the suspected current rating, I don't know. So that's what we have. So I'm going to ask you guys, if somebody gave you this and you weren't stupid enough to pay €10 for it like I did, would you use it for some sort of project? What would you do with it? Would you just use it for parts? Would you use it? Would you try to find somebody who actually wants a 100 volt line amplifier, albeit quite an old one? Or would you do something else with it? Would you make some sort of project and build this into this? I mean, make a nice case for some sort of dual output power supply, regardless if I use the parts that are in it. And that is really my thoughts on it. I've had €10 of fun, and I can probably have €10 more fun if I use the parts that I have here. So, guys, it's over to you. What would you do with it? And while you're thinking about that, and get into the comments below, I'll just say that I'll see you all on another Learning Electronics Repair video very soon. Ciao for now, guys.